Hello, I am Kamlesh and I have a post graduation and over I have 3.5 years for teaching experience. So today I will be teaching for grade 11 and the topic name is function in mathematics. So let us start with the topic. So the topic name is function. First we see the introduction of the function. As we know, in function, we have two non-empty set and F is a relation which is associate for every element A has the unique element of B that is called function for theoretical form. But today we discuss about the function in graphical representation. So the graphical representation of function. We know that the graph is highly important for the differential calculus. If we have a great knowledge of graph, then we can easily solve which question related in differential calculus. So we see the graphical representation of the function. It says no line parallel to y-axis meets the graph of the function at more than once. It means the statement it says, suppose we have any graph function like x square plus y square which is equal to a square. So this is a circle and the graph of circle this from the statement of graphical representation of function it says when we draw the parallel line of y-axis if it is cut more than 1 points. Here we see when we draw the parallel line through the y-axis and here we see it's cut one and more point. One and more point. It means the graph of x square plus y square which is a square which is not a function. Which is not a function. Suppose we have any other graph like the graph of y equal to x square. Then we can draw the graph of y equal to x square. So here the graph is like this. Here when we draw the parallel line of y-axis, here we see it's cut only 1 point. This is the parallel line of y-axis. It's cut only 1 point. It means the graph of y equal to x square is a function. Now we can take the some graph examples and check which is function or not. Suppose we have a graph like this. How to check this is a function or not? So here we draw the parallel line of y-axis and here we see it meets one and more points. One and more points. So this is not a function. Now next graph is suppose randomly we have graph like this. Now here if we draw the parallel line of y-axis, then we see it's cut only 1 point. It means this point are here, this graph, this, and it's got only one point. It means it is function. So here we see in graphical representation way how to say the given graph is function or not. Now we can see the next topic. Our next topic is domain. Domain. In theoretical form, we already know, suppose if A mapping F says that A tends to B, then the element of A, suppose it has A, B, C, and the element of B, suppose it is D, E, F, and where A is mapping D, B, C, C, and F. Here, set A is called domain, and the element of set B is called codomain. But in graphical form, how to find the domain? Here, any equation, suppose any curve y is equal to fx is the set of all real value of x in fx, which is called domain. Okay, now we have take some examples and check how to find the domain. Suppose we have a question like y equal to root under 5x minus 3. Then here how to find the domain? So first of all, we are squaring in both sides. So it's become y square equal to 5x minus 3. And we know that the square function which is always greater than equal to 0. It means here 5x minus 3 greater than equal to 0. It means 5x which is greater than equal to 3. Then x greater than equal to 3 by 5. It means here x belongs to 3 by 5 close interval comma infinity. So this is the domain for the given question. Now, so this is the concept of domain. Now we can discuss about some summarized form of range. 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 So the range of the function is the set of all real values. Set of all real values produced by the function. It means it says, suppose we have any function, then all the value produced by the given function, which is called range. Okay. So now we can see the classification of function one by one. So in classification of function, it has three types. First is algebraic. Algebraic function. Second one is transcendental. Transcendental function. And the third one is piecewise function. So today we will see the details of algebraic function, transcendental function, and piecewise function. And also we draw the graph of required function and we find domain and range of the given function. So algebraic function, it has type monomial function. Second is polynomial function. Today we discuss about this function are one by one for details to find their range, domain, also graph. Then next is rational function. And next one is irrational. Irrational function. So these are the algebraic function. Now, for transcendental function, it is classified as first is exponential function. Second is logarithm function. Logarithms function. Next one is trigonometry function. And next one is inverse trigonometric function. And another form is transcendental function, which are geometric curve. Geometry's curve. Now, we coming from piecewise function. Then these are types. First, modulus function. It is also called absolute value function. Then second one is greatest integer function, which is denoted as like that, modulus function, this form. Then signum function. Next one is least positive integer. So these are the form of piecewise function. These are the form of transcendental function, and these are the form of algebraic function. So in today class, here we can discuss the algebraic function, transcendental function, piecewise function one by one. So first we see the monomial function in algebraic function. In monomial function, it is a form of like y equal to a into x to the power n. And here a is not equal to 0 and n is any non-negative integer. So example of monomial function are like y equal to x square, y equal to x cube. These are the example of monomial function because this is the form of y equal to a into x to the power n. Now we can draw the graph of this function and also we can find the domain and range. So the graph of y equal to x square. Here we see this is a square function. It means first we draw the graph of this function and we know the graph of y is equal to x square. It is be like that. And how to find when we putting the value of x and we get y, then again we putting the value of x, then again we getting the value of y. So it has graph of like this. What we see here in this graph, we see it is symmetric about, which is symmetric about y-axis. It is symmetric about y-axis. It means it is even function. Even function. And also we say that f of x, where f of minus x, when we putting, then we get f of x. So it is an even function. Now here, when we discuss about its domain and range, for domain, it means we see the value of x, which is lies between plus infinity to minus infinity domain. It means where the curves lie, where the curves lie. And in this diagram, we see the curves lies between minus infinity to plus infinity, minus infinity to plus infinity. It means here domain x belongs to R. But what about the range? When we discuss about the range, we see this is a square function. This is a square function and no. And we know this square function which is always greater than equal to 0. It means it contains all positive real numbers. So its range where x belongs to 0 to close bracket, close interval, 0 to open interval, infinity. So here we see The monomial function y is equal to x square, which is an even function, which is symmetric about the y-axis, and here domain is x belongs to R, and the range is y belongs to 0 to infinity. Now, we can see the graph of second function. It means what? Y equal to x cube. So here, next graph is y equal to x cube. Now, we can draw the graph of y equal to x cube. It means when we draw the graph of y equal to x cube, this is the form of like that. And here we see this graph which is symmetric about the opposite quadrant. We see here which is symmetric about opposite quadrant. It means it has the first part graph of first quadrant and the second part of the graph is third quadrant. It means it is the opposite of its opposite quadrant, and it means it is odd function. Odd functions also give the information when we putting f of minus x, then we get minus of fx. So here we see for domain conditions. For domain condition we see here the curve which is lies between plus infinity to minus infinity. It means here domain x belongs to R, and the range which is also belongs to R. It is clear from this graph because the curve lies between plus infinity to minus infinity. So these are the two examples of monomial function. Okay. Now in algebraic function, the next form is polynomial function. Polynomial function. So for polynomial function, a function of the form of y equal to suppose a1, 1 minute. Here y equal to a naught first of all, then a1x plus a2 x to the power 2 and so on. And the last term is a and xn. Here in this expression, a naught which is not equal to 0 and the power of x which is non-negative integer. So this type of expression is called polynomial function. Now we can see some examples of polynomial function. So first of all, it has two types. One is identity function. This is the type of polynomial function, and we already discussed about the monomial function, which is also polynomial function, because the expression which is already form of y equal to a naught plus a1 and something that. So from identity function, it says any expression which is the form of fx equal to x. It means when you value the put, then the result will be the same. It means then that it has the graph like this form, f of x equal to x. So this is called identity function. And here in this graph, we see clearly here the domain belongs to R, because the line or the curve which is lies between minus infinity to plus infinity. Now from the range, we see which is also belongs to R. Now the second form of polynomial function is which is constant function. Okay, so in constant function, it has like this type of diagram. In this graph, here we see This is the form of like f of equal to c. Here, domain which is belongs to R, but the range, it's a constant function. So range belongs to C because it's a constant function. So in algebraic function, we can discuss about the monomial function and polynomial function. Now, the next function is rational function. Next one is rational function. We already know that any function which can be written as form like px divided by qx, this is called a rational function, and where qx which is not equal to 0. So we can understand the concept of rational function to take it this example, like f of x equal to 1 upon x. So first of all, we can draw the graph of this function. Suppose it's 1 upon x. It means the graph of 1 upon x be like this. And here the midpoint is 1, 1 and minus 1, minus 1. Then in this graph, here we already see the domain which is belong to the domain which is belongs to R minus 0, because when we putting x equal to 0, then function is undefined. So that's why here domain is R minus 0. Then what about the range? Range is also R minus 0. It is clear. And through this graph, we can see that it is a symmetric about opposite quadrant. Opposite quadrant. It means it is odd function, and here f of minus x, if we put it, then we get minus of fx. So this is the details of the graph of f of x equal to 1 upon x, and which is a rational form. Now we can see the another example. Like suppose if we have fx equal to 1 upon x square, then we see the numerator value is the square form, then the graph of this function, it would be like that. And about this graph, we can say that here domain which is equal to r minus 0, because if you're putting x equal to 0, then the function is undefined. So that's why domain here belongs to r minus 0. And what about the range? Range. Here we see the curve which is in a square form. It means its open side, the graph are open in upward side. It means its range is 0 to infinity. And again, here we see this is a even function. When we putting f of minus x, then we get f of x. And also here c, which is symmetric about, the graph form is symmetric about the what? Y-axis. So this is the details of rational function. Suppose we have any graph like the form of f of x equal to 1 upon x to the power 2n, and the another form of f of x equal to 1 upon x to the power 2n minus 1. So here, when we're putting the different value of n, then we get here what type of value? Like 1 upon x square, 1 upon x to the power 4, 1 upon x to the power 6. Like this. And for the second function, when we putting the value of n up to 0 to r, then here the values become x equal to 2n minus 1. It means 1 upon x, then x cube, next one is x to the power 5. Then the diagram or graph of all these functions, this can be drawn as like 1 upon x square. 1 upon x square, we already know that it is the form of this. Then what about the x4 and x6? So it can be drawn as like that. It is, the first function is y upon x square. And the next function is 1 upon x cube. The next function we can draw is like this. And the another form, it means 1 upon x6. So it can be drawn as like that, which is 1 upon x to the power 6. It is not touch on the y-axis. Okay, this line, it cannot be touch on that point. So this is the graph form of 1 upon x to the power 2n. Then similarly, we can draw the graph of 1 upon x to the power q, and 1 upon x to the power 5. In similar form, here we can draw the graph of like 1 upon x. So this is the graph of y equal to 1 upon x. Now the next graph is 1 upon x cube. So it can be drawn like that, which is y equal to 1 upon x cube. Now next one is, which is y is equal to 1 upon x to the power 5. So this is the some graph representation of rational function. And now we can see in algebraic function, the last function is, fourth function is irrational function. Irrational function. Any function which is, suppose any function whose the power is in a rationalized form, like 1 upon 2, 1 upon 3, x to the power 1 upon 4, x to the power 1 upon 5. So in this type of function, that is called a irrational function. Now we can see the graph of this function. So suppose we can take some example of irrational function. Suppose first function is y equal to root under x. And we know the graph of y equal to root under x, which is drawn like that. This. And according to this graph, we can say here domain which is belongs to 0 to infinity, and the range which is belongs to 0 to infinity. Okay. Now we can see the another example. Suppose y equal to x to the power 1 by 3. So how to draw the graph of this function? It is very simple. It is the inverse image of x cube. It means the meaning of that statement, and we know the graph of y equal to x cube, which is drawn like that. And the graph of y equal to x to the power 1 by 3, which is the mirror image of x to the power cube. So here the graph of y is equal to x cube, which is drawn like that. Here, this is a y equal to x cube, and this is the graph which is the mirror image of x cube, which is y equal to 1 upon x to the power 1 upon 3. So for this graph, here we see the domain which is belongs to R, and the range which is also belongs to R. So for the today class, to summarize, today we covered the topic is function, especially for the graphical representation of the function, then domain, range, and we can discuss the classification of function for algebraic function. We can take the examples of some algebraic function. It means it has monomial function, polynomial function, rational function, irrational function, and discuss about their domain, range. Then thank you for your time. I hope you find this season is informative. Thank you.